Hello guys, Wayne Fillmore here, and I'm coming at you guys live with another video at 8:07 a.m. in the morning. It is January 6th, 2017. How are you guys doing? So I wanted to make a video, and I want to say real quick, but I'm not sure how long the video actually is going to last. As a matter of fact, I'll set the clock for, I'll say, at least 20, 25 minutes tops. That's how long I'm planning on for this video to be. I don't want it to be too long, but basically, for the last couple of weeks, actually, I've been going through some somewhat complex mathematics, pre-calculus, physics equations, stuff like that. Real nerdy, geeky stuff. And I was finding a correlation between modern physics and the Bible. And I know how, in most of these new movies and documentaries, they're always like, oh, there's some type of secret mathematical code in the Bible and it's pi or some crap like that. I know you guys probably are used to hearing myths like this. However, I don't necessarily have a code, but what I do have are mathematical equations or proofs, mathematical numerical proofs for the divinity of the scriptures. So people often talk about evidences and proof and they equate the two to being the same thing. However, proof is actually a mathematical concept while evidences are not. So you can have evidences for something, but mathematical proofs are absolute. So we can mathematically prove things beyond a shadow of a doubt, and then evidences only take you but so far. But the math can only be interpreted in one specific way because mathematics, of course, is a language. And so when you think of math as a language, math is what we use to describe the nature of reality. We see patterns in nature and we write them down and we describe these patterns. We describe these observations with numbers, with equations. And so that is how we do physics. Now, I'm going to jump into this, and first we're going to get into a little bit of Euclidean geometry with along of Cartesian coordinates, and then we're actually going to get into the methodology of problem solving. Oh, and also there's a hint of pre-calculus in here for you math nerds. So let's just get into it. I'm going to share my screen, but before I do that, I'm actually going to set my timer. I was supposed to do that, but I didn't do it yet because, well, I was too busy talking. I wish I could see the live chat right now. Ask you guys how you guys been doing. If it's somebody watching at this point in time, which I don't think there is. It's early in the morning. It's 8:11 a.m. You guys are still sleeping. So I set the clock for 25 minutos. And let's go. All right, so I'm going to share my screen. Here we go. So if you guys can see my screen, right here, this is what I was talking about when I say we see observations in the natural world and we write down our observations with mathematical equations. So this right here is called Kepler's law. There's 3 laws that Kepler made that describe planetary motions. So this brief overview says Kepler's 3 laws of planetary motion can be stated as follows. All planets move about the sun in elliptical orbits, having the sun as one of the foci. Then it says a radius vector joining any planets to the sun sweeps out equal areas and equal lengths of time. And then there's a third one, but I'm not going to click on that because, well, then we'll be here for an extra 5 more minutes. But seriously, getting into this, I want to talk about Cartesian coordinates. Now you guys are like, what the heck is Cartesian coordinates? Okay, well, there's something called a Cartesian coordinate system, and this is basically a coordinate system that specifies each point unequally in a plane by a pair of numerical coordinates, which are the assigned distances to the point from two fixed perpendicular directed lines. And basically this just goes to show that, or I'll break it down in a way that's easiest for you guys to kind of understand. But when we are talking about geometry and shapes and measurements and etc., as a matter of fact, down right here, it's talking about Euclidean space and Euclidean geometry. When we do these things, all right, when we describe dimensions like this, these are actually dimensions, and each axis describes what dimension you're talking about. And so one dimension would be one axis, like an x-axis. Then the next dimension would be an x and a y axis, which would be a second dimension. And as you keep on going up in dimensions, you have to add another axis. And so you have two axes right here, an x and a y axis. And these are basically describing a two-dimensional space using Cartesian coordinates. And so we use these different coordinates so we can describe dimensions. Sometimes you can even use it so you can, it actually is mostly used when you're talking about geography, when you're talking about maps. But when you're talking about like geographical locations, y-axis, not because the actual places are two-dimensional, but because we're using a two-dimensional grid. We're using a map that's on a flat plane, that's on a flat piece of paper. And so that's basically an overview of Cartesian coordinates right here. So what exactly does this have to do with the Bible? Well, as you keep on going up in dimensions, like I said, there's an x and a y axis for two dimensions, but also there's an x, y, and z axis when you're talking about three-dimensional spaces. And so to describe our plane of space, we need to add an axis, which is the z axis. Now, actually, these values right here, x, y, and z, they don't necessarily have to be x, y, and z. These are just the values that were given to these axes by the guy who made it. He wasn't American. I think, if I'm right, I think it was French or something like that. But we could actually just replace these values with like A, B, and C, and it would still be the exact same thing. But we're familiar with naming these values x, y, and z. But as you keep on going up also too, so you have an x, a y, and a z axis to describe our dimension. And this is how we would describe a higher space or a hyperdimension. So in a 4D world, there is another directional axis which is perpendicular to the x, y, and z axis. We shall label this axis W and call the direction along the axis the fourth direction. The new axis also has positive and negative directions, which we shall refer to as positive W and negative W. And so this right here, this W, where they added this axis, this W going perpendicular would be the fourth dimension. So with string theory, we actually have discovered that there are at least 11 dimensions that hold together our third dimension, our third plane of space. And they all basically fit together like a layer cake. I'll try and find a picture for you guys. Show you. I'm searching. Here we go. And I think I found the perfect picture for you guys. Because I know some of you guys are visual. I know I'm visual. If I can't see it, I don't know what you're talking about. Okay, so I'm about to share this picture with you guys. There you go. So this actually right here is the perfect description of what I'm talking about when I say that there are at least 11 different dimensions and they hold our third dimension together like a layer cake, or almost you could think of it like an elevator. And so I guess even a novel prediction that that the Bible makes is that the heavens will roll up like a scroll. And when we're talking about dimensions and etc., um, so for an ancient text to say something like that, um, back in that day when they didn't understand dimensions, right? They didn't have like Euclidean geometry and stuff like that, so they can understand planes and spaces and stuff. And so, for an ancient book like Revelations to say that the heavens will roll up like a scroll, well, what does that mean? As a matter of fact, if I can, let me see if I can find a picture for you guys to even show you what that might look like. So, it actually be the perfect imagery for you guys. So, this actually is possible, um, but this isn't the picture to go with the verse. But this basically um, visually describes what that will look like for the heavens to roll up like a scroll. Now, people say, "Well, how can the heavens roll up like a scroll? The sky can't roll up." Well, not the actual blue sky that we see. Like the Earth isn't going to roll up or anything like that. Um, the easiest way to kind of even visualize this is the fabric of space. Okay, let me show you guys what the fabric of space looks like. Or the fabric of space-time. But this is the fabric of space and time. Like I said before in my other videos, it can bend, it can warp, and depending on the mass of an object, it bends time and space around it. Hence general relativity. Hence why light can bend, gravitational lensing. And so the fabric of space can bend, but we also know the fabric of space is flat, like a piece of paper. And so for the heavens or the fabric of space to roll up like a scroll, that actually is possible. And what we would see is that as this fabric of space is being rolled up from our third dimension, so the third dimension, which would be from this point to this point, having a beginning and an end, being rolled up, these dimensions at the bottom and the dimensions over at the top, over top of the third dimension, they would basically fill in that gap where that third dimension wouldn't exist. However, these other dimensions, these higher dimensions, and even the lower dimensions, they would take its place as if this dimension never existed. And so that's actually a novel prediction that the Bible makes, which mathematically and geometrically, it is possible. And before I make my next point, let me get into something else. So, share my screen again. All right, here we go. So let me get back into what I was talking about. Now, this right here, you guys probably have seen this picture before, and you guys probably haven't seen this picture before. But for those of you who haven't, and even for those of you who have, this is the famous Tesseract painting that was painted by one of my favorite painters of all time, Salvador Dali. As a matter of fact, the first time I heard about Salvador Dali, I think I was about 13 years old. They had an exhibit down at the Philadelphia Art Museum, and my cousin took me down to the art museum, and I will always remember that was the day I found out about Salvador Dali's painting with the lobster as a phone. Really original stuff. But something really did inspire him to make this painting. He saw something that I guess a lot of people in his day didn't see. But on a tesseract. Now, we live in the third dimension, but there are at least 11 dimensions holding our world or our existence together. And one of those dimensions, or one of those axes, would be time. And so we are trapped within the fabric of space-time, where we are time traveling right now, but we can only go one way. We can only go forward. We can't go backward. We are constantly decaying. Hence the laws of thermodynamics, first law, or second law. I'm sorry, the second law. So when we look out, even into everything in the universe, everything in the universe is running down in respect to the Earth, because we're getting energy. The Earth is being fed energy from the sun, hence why we have photosynthesis. A lot of creations got to get that right when they start talking about evolution and the second law and stuff like that. They got to get that right. But this picture is so magnificent because it's basically showing that Jesus' sacrifice on the cross, it transcends time. So a tesseract literally would be a 4-dimensional cross, and unraveled or unfolded, this 4D tesseract makes a 3-dimensional cross. But Dali didn't draw them on a cross, he drew them on a tesseract. And the tesseract would be a 4-dimensional object going into the dimension of time itself. And so basically this picture is saying that Jesus' sacrifice on the cross transcends this dimension throughout the fabric of the whole cosmos. So even if there's a multiverse out there somewhere, or even if there's aliens out there somewhere, because of biological evolution, random chance, and time, Jesus saved the universe. And if there's a multiverse out there, he saved that too. Now, I actually myself wrote out an equation to try my best, to the best of my little crappy math abilities, to describe the incarnation of Christ. The incarnation just means the housing. First John says, in the beginning was the Logos, or was the Word, and he tabernacled, or he became he became a person. He pitched his tent among us. And so the hyperdimensional, spaceless, timeless, eternal God became a man. And so I actually wrote an equation myself to mathematically try and describe the incarnation. And so this right here is my equation. And basically, if you guys are familiar, some equations start off on the left with the equal sign. And so this is the value right here. And so this is length times width times height, which is our 3 dimensions will be equivalent to, right? Or the incarnation itself will be equivalent to, this right here is the infinity sign divided by x spatial dimensions. Now, notice how this value, it isn't a number, it's a letter. And you guys are like, well, how come you didn't put how many, values this eternal being descended from? Well, that's the thing. We don't know. I don't know. I have no idea how many dimensions God had to descend to in order to get into our 3-dimensional plane of space, because his existence is higher than our 11 dimensions. And once you go past that, we don't know how many dimensions there are. We know about the ones that hold our existence together, but there's so many more that we don't know about. And it could be said they go on forever, and we don't know about forever. It's like pi. Pi goes on forever and ever and ever and ever. 3.14 ... And so this is my equation. And one of my friends actually said, well, you're getting pretty close to modalism. Well, actually, no. And I actually have a more complex equation than this. So on my Twitter page, I had wrote down the equation. I got a little bit more deeper into it, where I used sets. So in pre-calculus, you have sets. So these values right here, A, right? A is a set, B is a set. But inside of a set, you can have what's called elements, or you can have numbers. And these numbers would be equal to this set. So A equals the number of elements in this set. Now look at this. The elements that are in this set is infinity. And so you have infinity also in this set, right? And then you have infinity in this set. And so C equals an infinity amount of elements. Now, here's the thing. An infinite being, or even infinity divided by anything or subtracted by anything is still infinity. It goes on forever, even if you take a finite amount of numbers away. Think about the number line. If you guys are familiar with real numbers, what's the first real number that comes after 0 to the right? Well, that's the thing. There is no first real number that comes after 0 to the right, because you could literally put 0.0001, 0.001, 0.013. So a real number would just be a number that isn't imaginary. And so any number that isn't imaginary could go to the right of 0. However, if you take away one of those real numbers, right, you still would be able to get to 0. And so in the same sense, with this equation, or with the trinity itself, you could take away a finite amount of elements from a set, and this infinite set will still be infinite. And so you could say A equals B, B equals C, C equals A, but there's still only one God. And Hugh Ross, he actually wrote me back, and he said, here's another one. He said, the Father equals the Creator, Son equals the Creator, Holy Spirit equals the Creator, but there's only one Creator. And so that's basically another way you could put it if you don't want to deal with the numbers. But this would be actually the mathematics of the incarnation. The time. We have 6 minutes left. All right. So one more thing before I go. Let me dive into something else before I get finished. Now, problem solving art, right? And so the better you are at math, the more likely it is you'll be able to problem solve. And so this right here to the left is one of the guys my textbook uses, my pre-calculus textbook. They talk about this guy named George Polya. And so he was a famous mathematician who came up with a methodology, a 4-step methodology for problem solving. And so he says the first step in problem solving is to understand the problem. And so we have to find out what is the unknown, what are the given quantities, what are the given. Now, if you guys are familiar with the Ephesians study I've been talking about that was done by my and the physicist, General Han Solo, you can guys go over to his channel and check out his stuff. Look at the Ephesians study that he actually did. Notice how right here in number 1, so he actually says, one of the most direct and significant connections between the work of theologians and scientists lies in the methodology of what is truth. For example, Genesis 1 reads like a primer on the scientific method. And number 1 says it starts with an opening. Genesis 1 starts with an opening identifying the frame of reference and or the initial conditions. And what is the first step of problem solving that George Polya told us about? First steps of problem solving is the problem or understand the given conditions. And Genesis 1 starts out conditions. Then it talks about think of a plan between the given information and the unknown that enables you to calculate the unknown. It often helps to ask yourself explicitly, how can I relate the given to the unknown, etc. Try to recognize something familiar. Try to recognize. And so a lot of people I know who are atheists, just trying to find patterns. You're just trying to find something familiar when you're looking at God, when you're looking at theology. Duh. That's what we do in mathematics. That's what we do. That's what we do so we can problem solve. We have to try and find connections so we can solve the problem. And And so going even deeper, let me see. Here we go. Here's number 2. He says, use an analogy, introduce something extra, take cases, methodologies he has. Let me see. Oh, he even has right here, work backwards. This is a really good one. Work backwards. This is one, starts off, what does it say? It takes you to the beginning. It says, in the beginning, God created heaven and earth. And so step 1, or it takes you to the beginning, and then it starts with an initial point of reference, right? It gives you the initial conditions with the earth. It talks about the earth being unformed and desolate, is dark on the surface of the waters, and the Holy Spirit is hovering over the surface of the waters. And so it gives you a beginning where it works backwards. It gives you initial conditions. And if you keep on going, and to George Polya's work, he said plan. A plan was devised, and carrying out that plan, you plan or write the details that prove is correct. Yeah, as you keep on going in Genesis as well, and let me show you guys in the Ephesians study. So number 2, an orderly description of a sequence of events. And that's what we see in Polya's method. Is on carrying out a plan. And so that's what we see. We see a sequence of events in Genesis 1. And then number 3, we see a closing on the final conditions with some conclusions. And so all in basically the first chapter of the Bible in Genesis 1, we see the problem solving in this ancient Near Eastern text. And then it says, look back, having completed your solution, it is wise to look back over it, partly to see whether any errors have made in or partly to see whether you can discover an easier way to solve the problems. And so this would relate to the other creation passages in the Bible that validate the Genesis 1 creation account, like Psalm 104, as a matter of fact. And let me show you guys what I'm talking about so you guys know I'm not talking on my butt. When it comes to Genesis, well, there are other creation passages in the Bible that more descriptions on creation that Genesis 1 missed out on. So Psalm 104 is a perfect example. So in verse 2, it talks about he wraps himself in light as with a garment. He stretches out the heavens like a tent. But notice how in Genesis 1, it says, in the beginning, God created the heaven and the earth, and God said, let there be light, and there was light. And then Psalm 104 verse 2 says, he wraps himself in light with a garment. He stretches out the heavens like a tent. Who alone stretches out the heavens and tramples down the waves of the sea. This is Job 9 verse 8. Several creation passages refer to the expansion of the universe. And so we check our work to see if one verse or one chapter, etc., is correct by going back from the other creation passages in the Bible, and it validates what that first one said. And so like a scientific primer or like a mathematical method, George Polya, to be even more specific, this ancient Near Eastern book uses problem-solving methodology in it. It even goes on to basically describe Euclidean geometry, mathematics, equations, etc. And so if this is just a theology that was written by men, why is it so sophisticated where even the most brilliant mathematician or scientist at our time can see modern connections in this ancient Near Eastern book? However, the people who wrote the book didn't know about these modern things. They didn't know about Euclidean geometry. They didn't know about Cartesian coordinates. They didn't know about physics or equations. But why is the book able to make these connections? Did these ancient people just sit around and say, hey, we're going to sit around, we're going to write about something called the Trinity, and we're not going to be able to explain it, but it's still going to be logically, mathematically valid. I mean, how reasonable is that when you're saying people thought the earth was flat? Or maybe what they wrote down really is true. Maybe it just was inspired, like they're saying it was. So you have a dilemma. Either their work truly is inspired by God, or it's not inspired by God, and these people were just mathematical geniuses. Either way, you have a dilemma that you need to be able to explain. And if you disagree, I would love to see your rebuttal and your explanation against the work that I've presented and the work that others have presented as well. I think I've done it the best though. But with that being the case, somebody got some explaining to do. So if you don't believe in the Bible, I would love to see your critique of this explanation. And who knows? Maybe we're just on different sides of the equal sign with different descriptions. Who knows? So you present your equation and I present mine's, and let's see what happens. All right, guys, I'll talk to you later.